hot dog, hot diggity dog. Yep, we have a hot dog problem. Who ate more hot dogs for dinner? Oh man, those hot dogs are good. Well, Sam over here ate what? He didn't eat a whole hot dog. How do I know that? Could you tell me right now, out loud? Like, how do I know Sam didn't eat the whole hot dog? Because he's just looking at it and he hasn't taken a bite yet? No. This is before he started eating it. Okay, right here, what is this? This is a fraction. That means he ate a part of the hot dog. He didn't eat the whole thing. And if he did, this would say 4/4. This only says 1/4. Okay, how about this guy? This is Joey. What did he have to eat? Well, this looks like a fraction too, but it's kind of a weird one. He ate 3 halves. Hot dogs. Huh. So who ate more? Was it Sam? Or was it Joey? You're like, oh, I know this. Okay, well, can you prove it? How would you prove it? Okay, pause the video, try it out. So, man, right away, boom, I see something. And it tells me something, and I know within 3 seconds what it is. Why? Because of this right here. This guy, I'll highlight it. You know what I'm going to highlight? Oh, man. No, not his eyeball. I'm going to highlight this. This right here. That, why did I say that was weird? Well, it's not a typical fraction. It is an improper fraction. Look at this. This is 3 of the halves. Oh, man. So when I'm making in my head or on paper a number line from 0 to 1, and I'm thinking of a fraction, and I'm working in halves, well, I cut it in half, and I'd have my half, right? And 1 would be equivalent to 2 halves. So I'd say, okay, he didn't eat half, 1/2. He didn't eat 2 halves. Oh my gosh, he had more than that. He had 3 halves. So I'm going to extend my line. Now, when I extend it, I'm going to go to the next whole number, which is 2. And between 1 and 2, I cut it in halves. And now I still have the same chunk happening over and over again. Right here, I have a half. I have another half. I have another half. I have another half. These are all halves. And how many halves did he eat? Well, he had half, 1/2. He had 2 halves. He had 3 halves. As you can see, he has eaten more than 1 hot dog. He hasn't eaten 2, but he's eaten 1 and another what? What is this worth? These were what? These were halves. He's eaten 1.5 hot dogs. Yeah, he had this whole hot dog, then he had another one, but he only had half of it. And he's like, oh my God, that's too much. Okay. But Sam over here, did he eat more than 1 hot dog? No, because 1/4, is that improper? No, this 1 is smaller than the 4, meaning when I break up my line from 0 to 1, I'm not breaking it in halves, I'm breaking it in fourths. Am I going to go beyond 1 whole hot dog? Well, 1 whole hot dog, if we're working in fourths, would be 4/4. Did he have 4/4 or more than that? No, he only had 1 of those fourths. So out of this hot dog, if I chop that up into 4 parts, he really is only going to eat that much and then decide, I actually don't want this hot dog anymore. Okay, so I'm able to say that 1/4 or Sam had less hot dogs than Joey, who had 3 halves hot dogs. And how do I know this? Because 3 halves is more than 1, whereas 1/4 is less than 1. Okay? I can use my ideas of ones. So when I'm comparing fractions to 1, I can right away, when I see these two and it's being asked of me to compare them, I know instantly which one's more, because I see an improper fraction and I see one that's a regular fraction. This guy's a regular guy. This one's improper, meaning 8 is more than 5. So I'm going to have a number that's more than 1, because 5/5 would be 1. And we have more than that. So right away, boom, I'm able to say more. This one, boom, I'm able to say this one's more, because it's improper. It's more than 1, whereas this one is not. And here I can see it instantly. Boom. Which one's more? You got it? Say it out loud. It's not 3/4, because that's not improper. 8/7 is more than 7/7, which is just 1 whole. So I'm able to, boom, say 8/7 is more than 3/4. Those work out really nice. Well, let's take a look at a situation with chocolate and Hershey's chocolate that is so good on a s'more. Okay, so here's a Hershey's chocolate bar, and we have Freddie who ate this much of that chocolate bar, 3/4 of it. But then you have Rosalia who ate 11/12 of it. Oh gosh, what do you think of this one? Try it out. Try something. Pause the video, try it out. And then press play. Okay? All right, as I think this out, 3/4 of the bar? Oh my gosh. Well, instantly in my head, I'm going, well, 1 whole bar would be 4/4 of the bar, 4/4. But Freddie ate 3 of those fourths. So, man, that's close. That is close to 1 whole bar. Okay, that's close to the whole thing. 11/12. Well, the whole thing, if I'm working in twelfths, would be 12/12. And she had 11 of those 12ths. Man, that is close. That is really close to the whole thing. Okay, so they're actually both close to the whole bar. Man, so did they both have the same amount? Well, let's check it out in a number line here, okay? And let's say we go from 0 to 1, always with our fractionness here. And one of them is working in fourths. So here I'm going to say, well, 1 is 4/4. And if I plot that out and I do my fourths and I make 4 parts and then I label, okay, he didn't have 1/4, he didn't have 2/4, he had 3/4 right here, 3/4. That's Mr. Freddie right here, 3/4 of the bar. How much did he have to go? He only had 1/4 of the bar left. Okay, that's 1/4 away from being the whole bar. Whereas Rosalia here, from 0 to 1, she was not working in fourths. She was putting them into twelfths. Okay, so now I'd have to make 12 parts. Holy cow, that's a lot. So let's say I didn't want to do that. Well, 11/12, well, I know 1 is going to be 12/12. Well, where would 11/12 be? Well, right next to it. Okay, without having to make 12 parts, I'm just going to say, well, 11/12 is going to be like really close to 12/12. And how far is that to 1? Well, that's only 1/12 away from 1 whole bar. So who's closer to eating the whole bar? Is 1/12 or is 1/4? Like, who has more left over? Is 1/4 going to be a bigger piece left over than 1/12? Yeah, because if I take something and I chop it up into 4 parts versus taking something and chopping it up into 12, the 12 parts are going to be smaller. So this chunk is actually smaller. It is closer to 1. It's closer to the whole bar. So Rosalia ended up eating more. Why? Because 11/12 is closer to 1 whole bar. It's closer. Now, what's really nice about Hershey's chocolates is I could actually visually chop this up into 4 parts right here. So here is Freddie, who chopped it up into 4 parts, and he had 1, 2, 3. So there was Freddie. He had that much of the chocolate bar, okay? Whereas Rosalia, if I erase what I did there, well, actually, I'll just use a different marker, blue. She was working with 12ths instead of 4ths. So can I break this chocolate bar up into 12? Well, yeah, I can, because look at, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 pieces, you guys. So I could actually go like this, just like the Hershey bar, chop it up into those 12 parts. And she had 11 of them. She had all this that Freddie had, all that he had, all that, and 2 more little pieces. And she only had that chunk left over, okay? Whereas he had this whole chunk left over. So Rosalia at 11/12 was more. So let's look at some fractions here that are both really close to 1, but who's closer? Who is greater? So here I'm working in twelfths. So 11/12 is 1/12 away from 1. Whereas 5/6 is how many sixths away from 1? It's 1/6 away from 1. So which one is closer to 1? Well, this piece is smaller, so this one is going to be closer to 1. 1/6 is a bigger chunk, so when I'm looking at 1, 1/6 is going to be farther away, whereas 1/12 is a smaller chunk, so it'll be closer to 1. Okay? And if I know that, then I'm able to compare them, because if 11/12 is closer to 1, then I know that it is greater. All right? Okay, we can use 1 to help us figure out hot dog situations, chocolate situations, and many other situations. Okay? All right, let's do it. We're number 1.